So somebody asked a very difficult question, which is why do the nasal fibers cross in the chiasm? And it would seem to be a simple answer, but it's not. And just as an aside, why questions are usually hard. And at some point, terminal why is going to be metaphysical or spiritual or religious. But this why happens to have an answer. And so if you're a layperson, you might think that the optic nerve in the right eye and the left eye just hooks up to the right side and the left side of your brain. That would just make sense, right? It just goes straight across. However, somewhere along the line in our evolutionary development, we decided, like you're some sort of worm crawling around the base of the ocean, that you want to move your spinal cord up to the top here and provide it with some protection from the bottom. Over time, what you're going to do is protect it with a rigid cord called the notochord that characterizes pre-chordate animals, and then you're going to have vertebrae, and that's going to be vertebrate. So you're going to go from notochord to chordate to vertebra, and that's going to happen evolutionarily as we're making our way up from the primordial sea. And so what happens when you make that switch, what you have to do is you have to have your little worm guy switch. So there has to be a somatic twist that occurs. That somatic twist will cause not only the optic chiasm to be a crossing fiber, but the whole right side of your brain is going to be controlling the left side of your body. And the left side of your brain is controlling the right side of your body, because in order to make that change without affecting your head, you had to switch sides. And so this is known as the somatic twist hypothesis. It's not clear if it's proven or not, but that somatic twist hypothesis means that the chiasm, the crossing of the fibers, in this case the nasal fibers, and the uncrossed temporal fibers produce what you know clinically as homonymous hemianopsias. So a left homonymous hemianopsia is going to be from a right-sided lesion behind the chiasm, and if you have hemiparesis, it'll be the same. The left hemiparesis will also be on the contralateral side. And one of the weird things that this somatic twist hypothesis that occurred on an embryologic and also on an evolutionary basis does is when you give a hug or a kiss. So if you're going to give someone a hug, you're going to use your right arm, and so when you hug someone versus when you kiss someone, you're going to be the head tilt to the right. In the hug, it's the opposite. So the body and the head are going to go opposite ways on the hug and the kiss because of the somatic twist. This is the basis of the nasal crossing fiber and also crossing of everything else, causing the hemiparesis, the hemisensory loss, and the homonymous hemianopsia to be on the contralateral side. And presumably there was some evolutionary advantage to moving the nervous system from the ventral surface to the dorsal surface. And then when we stood up, climbed out of the sea, and now you're like this, now it's even more obvious that the dorsum is displaced from when we swam in the ocean. So the short answer to your question, the somatic twist hypothesis.